In class, we've been talking a lot about compounding interest and talking about how much money you'd have in the bank if you put your money in the bank and you gain interest on it. And we've been talking about things like compounding the interest annually versus quarterly and monthly and things like that. Well, in this video, we're going to talk about something called compounding interest continuously. Right? That means we're not going to wait till the end of the month to compound the interest. We're not going to wait till the end of the year or the end of the quarter. The interest is going to be compounded constantly or continuously. Right? And we're going to talk about what that does to your money. All right, so let's look at this example. All right, so we want to deposit $8,000 in the bank. Right? And let's say we're going to compare, you find 4 banks. And for all 4 of these banks, we're going to say that they all offer a 2% annual interest rate, right? So the same annual interest rate, right? But here's going to be the difference. There are 4 banks here. Bank F is going to compound the interest once per year. Bank G is going to compound the interest quarterly. Bank H is going to compound the interest monthly. Bank A is going to compound the interest continuously. All right? So we've talked about these 3. So that's going to be kind of a review. The new one we're going to save to the end is going to be what's going to happen when the interest is compounded constantly or what we call continuously. All right, and we're going to compare what happens after 3 years. Okay, so let's go ahead and start the beginning ones, right? So F, G, and H, those are review, right? So we can set up our formulas. So to calculate the money in our bank for Bank F, if we deposit $8,000, right? So I'm going to use a function, f of t, right, where f represents the amount of money in our bank for Bank F, and of course t is time measured in years. All right, so f of t would be 8,000 times 100% plus 2%, right? It's our original amount, 100% plus 2%. Right, so we could either write that like this, 1 plus 0.02, and then to the power of t, or more commonly, we're going to write it this way. F of t is going to be equal to 8,000 times 1.02 to the power of t. Right? And that's our basic growth equation that we've been working with. Right? So that's f of t. What would g of t be? Right? Well, if we're compounding quarterly, that means in 1 year, the interest is going to be compounded 4 times. Right? So we would have to divide up this 2% into 4 equal pieces. Right, so what would be our formula for Bank G? So G of t would be 8,000 times 1 plus, and we're going to divide that 2% into 4 equal pieces. So 1 plus 0.02 over 4, and then we're going to raise this to the 4 times t power. Right, and why do we have to multiply the time by 4? Right, well, because remember, this time is measured in years. Right? And in 1 year, there's 4 quarters, right? So if, for example, if this was time is 2, well, 2 times 4 is 8, right? 8 quarters have passed. Right? So this would be our formula for G. And then for H of t, that's if the interest is compounded monthly, right? That's going to be 8,000 times 1 plus 0.02 divided by 12 to the 12t, right? And in this case, if we're compounding it monthly, right, that means the interest has to be divided up into 12 parts, right, because there's 12 months in a year. So we're dividing by 12 here, and then also, because time is measured in years, right, we'd have to multiply that by 12 to find the number of times the interest is compounded. Right, so those are our 3 formulas, F, G, and H. Right, and so we've been using those a lot in class. So if we were to calculate for 3 years, what would happen? So f of 3, that would be just 8,000 times 1.02 to the 3rd power. And when you plug that into your calculator, you get 8,489 and 66 cents. Okay. For G, if we plugged in 3 for G, G of 3 would be 8,000 times 1 plus 0.02 divided by 4 to the, in this case, 4 times 3 power, right? Or we could say to the 12th power, right? And if you plug that into your calculator, G of 3 is going to give you 8,000 $493.42. Right? And then if I'll do H over here. So if I plug in 3 into H, that's going to give me 8,000 times 1 plus 0.02 over 12 to the 12 times 3, right? Or we could say 36 here. Right? And when you plug that into your calculator, H of 3 is going to be $8,494.27. All right, so if you can compare these three values, right, you should see that the more times that you compound interest, the better you get, the more money you get, right? So far, the best one was the monthly. This is the one that got you the most money, right? Well, now we're going to do continuously, right? And you'll see that this actually is the best. Okay, sorry, my handwriting is not so good on this iPad, but all right, we're going to do it compounding continuously. All right, and the formula for compounding continuously is as follows. I need to give you this formula. All right, we'll call this A of t is equal to P times E to the RT. Okay. All right, so let's talk about what these things are. All right, so A, this is of course the amount of money in our account. Amount in our account. Oops. Okay. P, that's what in finance they call the principal. Principal. Okay, this is a C here. All right, that's the principal. That's how much you start with. All right. R, this R here, that's the rate. Right, that's the percent that you have from the bank. Okay, and then the new thing that you need to know is this number here, E. And you'll notice that I called E a number. Right? That's because E here is a number. It's kind of like pi, right? You've learned about pi as 3.141 ... It's a number that goes on forever, right? E is also a number, right? And it's the special number that comes up when we have things that compound continuously. And there's more to it than that, but we can talk more about that later. But E is a number, right? E is this number that's approximately 2.71828 It just goes on forever, just like pi. Okay, so in order to compound something continuously, we need this special number E. Okay, all right. So let's go ahead and work this out. Okay, so again, our formula is P times E to the RT. Right? It's actually pretty easy to remember. A lot of people remember this by saying PERT. Okay, so we want to go back to our account and figure out how much would we have if we deposit $8,000 and we compound the interest continuously. Right? So after 3 years, what would happen? So A of 3 would be our principal, or our initial value, which was 8,000. That's how much we deposited, times this special number E to our rate. This was a 2% rate, right? So it's 0.02 times time, which was 3. Right? And this you can plug into your calculator. So A of 3, right? And you'll find that on your calculator you have an E button, right? And we'll go over how to find that in class. But you would just plug this in just like this: 8,000 times E raised to the 0.02 times 3. Right? That's how you'd enter it into your calculator, right? And like I said, we'll talk about where the E button is on your calculator. Right, but it turns out that if you calculate this, A of 3 is going to be $8,494.69. Okay, and you'll see, again, that when you compound continuously, that's when you get the most bang for your buck. I went ahead and calculated a whole bunch of these. Right? Remember, Bank F was if we compounded just once annually. Bank G was if we compounded quarterly. Bank H was monthly. And Bank A was continuously. And you should see that compounding continuously always gives us the most money. Right? In some cases, it's not a huge amount, right? But it is going to be the best way to calculate your money. And you're going to find that in a lot of financial institutions, compounding continuously is what happens. Right? So this is going to be very useful in things like finance. Okay, we're going to look at one more example here. Okay, we're going to deposit $3,000 in a bank that gives us 4% annual interest, and we're going to do it compounding it continuously. Oops, this should have said continuously, not continually. All right, and we're going to figure out how much after 5 years. Okay, so let's remind ourselves. Our formula, I'm going to say this a bunch of times here, is this: P times E to the RT. Okay, so in this case, our amount in our bank is going to be 3,000 times E raised to the rate. In this case, it's 4%, so 0.04 times time. Okay, so this is our formula, right? This is our principal, and then this is our rate, the 4%. Okay, and then you got to remember E is that special number. Okay, 2.718. Okay, so let's go ahead and figure out how much money we would have after 5 years. So after 5 years, we're going to calculate A of 5. So that would be 3,000 times E to the 0.04 times 5. Okay, and again, we're going to use our calculators for this. There's a special E button. 3,000 times E, we'd put it in like this: to the 0.04 times 5. Okay, and when you plug that into your calculator, you are going to get something like this: $3,664.21. Okay, so that's how much we would have after 5 years. Okay, and then the last thing is ask us, how long would it take for us to double our money? Okay, so how long would it take for us to double our money? Okay, well, remember, our equation here for our amount in our account was 3,000 times E to the 0.04 to the T power. So we want to see, when will this be doubled? In other words, when will that be equal to 6,000? So we can set our equation equal to 6,000 and go ahead and solve. First thing I'm going to do is divide both sides by 3,000. And then I get 2 is equal to E to the 0.04 times T. Okay, and then we need to use a logarithm here. Right? So if we use a logarithm, this is going to be log base E of 2 equals 0.04 times T. Okay, now here's where I need to tell you something special. Right? There is, whenever we have a base of E, we use a special kind of logarithm. Right? And it's called the natural logarithm. Right? So this is actually the same thing as saying the natural logarithm of 2 equals 0.04 t. Okay, so whenever you see this, this is an ln. ln, that stands for natural logarithm. Right? All this means is logarithm that has a base of e. So logarithm with base e of 2 equals 0.04 t. Right? We say this either as ln or natural log. The natural log of 2. That just means we have a base of e. Okay, and then, so we have the natural log of 2 equals 0.04 times t, and then we just need to divide both sides by 0.04. Right? And if you plug that into your calculator, you're going to get 17.3 years. Right? And you will find on your calculator that there is a natural log button. Okay? All right, just real quick, let me just do a quick summary of the things that you need to know from this video. Right? The big thing is this formula. Right? When you're compounding continuously, your amount in your account is equal to your principal times E raised to the RT. And you got to remember, E is a special number that's about 2.718, and it goes on forever. Okay? And the other thing that you really need to know is when I have a log with a base of e, let's say I have log base e of 2, right? We don't typically write it that way, right? Instead, right, we would write it this way. Right? And again, this means natural log. All that means is a log that has a base of e. Okay, so these are the 3 big ideas you really need to know.